Hello, boys and girls. I'm sorry, but Dr. Rothfeld, Dr. Nicholas, and myself, we could not be in the building today. We are over in Cary receiving top secret training. And that's correct. When we get back, it will stay a secret. But in the meantime, it'd be nice for you to practice some problems, math problems, where we're going to use nets to find the surface area. Now, I think you're pretty familiar with the concept of nets. We're not talking about fishing nets. We're talking about the skin or the peel of these polyhedrons, these prisms and pyramids that we've been looking at. And when you peel back the skin or the panels of these polyhedrons, what you're left with is an arrangement of polygons. And for the most part, what we're dealing with, all of these polygons will be rectangles and triangles, which you guys are experts at finding the area of these polygons. Although when it comes to triangles, you still forget the last step of divide by 2. It's base times height divided by 2. Don't forget the last step. And some of you just get crazy on dividing everything by 2. Only do it with the triangle. So let's get it straight. Anyway, let's practice some problems together so that we can find the surface area of these polyhedrons. Boys and girls, let's look at problem number 1. Problem number 1 deals with we have a rectangular prism. What we need to do with this rectangular prism is flatten it out, unfold it into its net. A net will display all of the different panels or faces that make up this rectangular prism. Rectangular prisms, even they have 6 sides altogether, and I kind of, to save some time, I have the net already laid out, and I just want to help you identify the different parts. I like to start with the base. Okay, the base first. Let's say the base here is this section right in here. Okay, or I should say call it the bottom. Okay, we have the bottom, and this bottom section here is 6 2/3 meters wide, so it's 6 2/3 meters wide. Okay, and that would be right here. This would be the bottom. Okay, and it's also 5 1/2 meters long. We can see right there. This bottom happens to also have a twin, which is the top or the lid up here. And that would be here because we kind of have to wrap around. So that the top up here, this section up here, is the top, and it would have the same identical dimensions. It would be 6 2/3 meters wide. In fact, all of these rectangles here, all these faces will have the same width, and it will be 5 1/2 meters long. Okay, now let's take a look at, we have a front and a back panel. Let's change our color up a little bit. Let's go with blue. Okay, when I'm talking about the front panel, I'm talking about this guy right in here. Okay, this is the front right in here. Okay, and if this is the bottom, this would be the front that I'd fold up, and it's 6 2/3 meters wide, just like the other rectangles. But what is the length? Well, the length would be this edge right here, which is 10 meters. So this is our front panel, and we can see that it is 6 2/3 meters wide, and it is 10 meters long. And this front has an identical twin in the back here. I hope that helps a little bit. Let's see, it's that region back there. It's this back panel back here. Okay, that's our back, and it would be folded around here, and it would have the identical dimensions. All of these are 6 2/3 meters wide and 10 meters long. Okay, so that takes care of our bottom and our top, and then we have a right and a left. Okay, we have a right panel here and a left panel over here. Our right panel, okay, is 5 1/2 meters wide, and when we drop it down, Okay, when we fold it down, it's going to fall. This edge here is the length of it, so it's 10 meters. And see, this side and this side, they share the same edge, so that makes sense. When I fold this up and I fold the back up, they're both going to share this edge, which is 10 meters. And the same thing is true of the length of my left side panel over here. Okay, now let's find the area. Well, my front and back, my front is the dimensions of that. I get the area would be by taking the length times the width. So it's 6 2/3 meters wide. Going a little out of order here. And then the length would be 10 meters. And I'll put my M in there too when I label everything. I'm going to change my 6 2/3 meters into an improper fraction, which would be 20/3, and then multiply that by 10/1. And what I'll get is I'll get 200/3, and 200/3 reduces to 66 2/3 meters squared. Now the meters squared came from over here, and I didn't show it all the way through, but it's meters times meters. So I'll have the front and the back are both 66 2/3 meters squared. And I have a front and back, so I have to double that, and after I double it, I'll have 132 4/3 meters squared. I know this is an improper fraction. I'll clean it up later when I'm done totaling everything. Let's move on to the top and the bottom. Okay, our top and bottom have a length of 5.5 meters. Okay, that's the length, and the width is 6 2/3 meters. Let's change both of these to improper fractions. Okay, my 5.5 would become 11 halves, and my 6 2/3 would become 20 thirds. I multiply straight through. I get 220. 11 times 20 is 220, and then 2 times 3 is 6. 6 goes into 220 36 times, and 4/6 left over. And I can reduce this to 36 2/3 meters squared. So I have 36 2/3 meters squared. And when I double that, I get, because I do have a top and bottom that are identical, I get 72 4/3 meters squared. Let's move on to our left and our right. Our left and right panels are both 5.5 by 10 meters. 5.5 meters times 10 meters. 5.5 becomes 11 halves times 10/1, which will give me 110/2, which will reduce to 55 meters squared. And when I double that, I will get 110 meters squared. Well, let's all add it up. 4/3 and 4/3 would be 8/3. And 2 and 2 and 0 is 4. 3, 7, and 1 is 11. Carry the 1. 1, 1, and 1 is 3. So I have 314 8/3. Let's clean that up a little bit. That'll be 316 2/3 meters squared. Just fits. A lot of calculations. That was round one. Let's try round two. Boys and girls, let's take a careful look at number 2. Number 2, we see we have a triangular prism. Now, triangular prisms, of and in themselves, are really not that difficult in comparison to other prisms when we're looking for the surface area or making nets. In fact, making the net's not that big of a deal, but we got to be careful, and we got to be careful with assuming things. We're going to have no problem seeing that this bottom here rectangle would be placed right there, that this has a front and back triangle that form the front and back faces, and then when we flip this front panel out here, that'll be the right, and when we flip this one down, it'll be the left panel, which they all form. You have 3 rectangles and 2 triangles. The difficulty is not there. It's when we start finding the dimensions of these triangles. When we see a triangle like this, we automatically want to assume that this edge right here is the base. After all, it's on the bottom. But just because this edge here, this line segment, is on the bottom, the triangle is resting on that, that does not make it the base. The base of a triangle is always formed, especially a right triangle, is formed where the right triangle, where you have a right angle, and the base and the height, they intersect to form a right angle. See, and what's opposite? What's opposite? This is the hypotenuse. Okay, this side here is the hypotenuse, and I can prove that on a couple levels. One, when you have a right triangle, the hypotenuse is always directly across from the right angle, so it can't be the base. Also, when you have a right triangle, the hypotenuse is always the longest side, not the base. Okay, and here we see the base is 3 centimeters. This side over here, this edge here, I should say, runs parallel to this edge here, so they share the same length. This has a length of 4 centimeters. This edge here is 5 centimeters. It's the longest side of the triangle. Therefore, once again, it's the hypotenuse, not the base. So be careful. When you see a right triangle, make sure that you have the base and the height labeled correctly. The hypotenuse, we really don't need to find the area of this triangle. It'll be helpful though with this bottom rectangle. Okay, so there we have it. Let's label this hypotenuse here. This edge is also the width of our bottom rectangle, which is 5 centimeters. It then would have the length of 3 1/3 centimeters. And I'm going to convert this 3 1/3 to 10/3 times 5/1, and that will give me 50/3. And when I reduce 50/3, that will be equal to 16 2/3 centimeters squared. And I got the centimeters squared from centimeters times centimeters. I just didn't transfer that label all the way through till the end. Okay, but there is the area of our bottom face. So I can put that in right now. That's 16 2/3 centimeters squared. Okay, well, if this is 3 1/3 centimeters long, then the width is 4 centimeters. Okay, and keep in mind this edge and this edge are shared, so they are the same. Okay, and the same is true with this. This is 4 centimeters, and this edge are shared, so they're the same length, 4 centimeters. Okay, so we have a 3 1/3 times 4 centimeters. We will change this once again to, I'm just going right down here, 10/3 centimeters times 4/1, which will give us 40/3. And 3 will go into 40 13 times, and I'll have 1/3 centimeters squared left over. So my right will be 13 1/3 centimeters squared. Okay, so we have that right panel taken care of. Let's take care of the left. Okay, we know that the left here, once again, it's 3 1/3 centimeters long. It would be 3, according to this, okay, right here. See, that's our 3 1/3, and then the length of it, or the width of it, yeah, is 3 centimeters. And this edge is shared with this edge. They're the same. Okay, so we have 3 1/3 centimeters times 3 centimeters. This becomes 10/3 centimeters times 3/1 centimeters. We get 30 thirds centimeters, which I think we all know will be going off by 10 centimeters squared. So yeah, the left is 10 centimeters squared even. Okay, now here comes our triangle. Our triangle, okay, has a base of 3, a height of 4. We know that area is equal to base times height divided by 2. So we have a base of 3, a height of 4. We divide that by 2. The 2 and the 4 we can cross cancel. The 2 becomes a 1, the 4 becomes a 2, and we get 6 centimeters squared. That is the area of one of the triangular faces, but we have 2 of them, and when we double it, we'll get 12 centimeters squared. And let's add this all up. We're going to get 1/3 plus 2/3, which is 3/3. And then 2 and 3 is 5, plus 6 is 11. Carry the 1. We get 1, 2, 3, 4, 5. We get 51 3/3 centimeters, or 52 centimeters squared is our final answer. Boys and girls, I promise to speed up problems 3 and 4. Boys and girls, number 3, we have a square pyramid. Okay, it is a pyramid because it has one base, and then opposite of the base we have a vertice that is the pinnacle. It's the high point. It only has one base, not 2. If it had 2 bases that were identical, then it would be a prism, but that's not the case. And then also, too, what's typical of a pyramid is all of the side faces are triangles. And these are kind of neat. They're easy to diagram the nets. We can just kind of imagine all 4 of the side faces, these triangles, just falling downward, and it opens up like a flower, each one of these being a petal, but the petals are triangles. And all of these triangles are identical triangles. Let's start labeling, though. We see here that the square, each side has a length of 6 inches. Okay, and this side and this side and this side, they all have equal lengths. And then the triangle has a height. The base would be 6 inches, and the height would be 11.3 inches. And that's really all we need. We can now start our calculations. We know that the square is 6 by 6, which would give us 36 inches squared. I'll put that right up there. And we only have one base, so we don't need to multiply that. That's 36 inches squared. And then our triangle has we know that our triangle formula, area is equal to base times height. Please don't forget to divide by 2. That's the one step you guys forget way too often. But our base is 6 inches. Our height is 11.3 inches. And when we multiply those two together, oh, well, let's not forget to divide by 2. See, I almost forgot it. In fact, let's cross cancel. 2 will go into 2 once, and 2 will go into 6 3 times, and this will actually make the multiplication a lot easier. 3 times 3 tenths is 9 tenths. Oops, I forgot my inches. Well, okay, I'm getting ahead of myself here. I know that inch times inch will be inches squared. Okay, as I was saying, 3 times 3 tenths is 9 tenths, and then 3 times 1 is 3, and 3 times 10 is 30. So our area for just one of these triangular faces is 33 and 9 inches squared. And when I take 33 and 9 tenths inches squared and multiply it by 4, since there's 4 identical triangles, we will get the product of 135 and 6 tenths inches squared. Our last step is just to add everything up. And when we do that, we have to add our base to our 4 side faces. 6 tenths plus 0 is 6 tenths. 6 plus 5 is 11. Carry the 1. 1 plus 3 is 7. And bring down the 1. Our answer is 171 and 6 tenths inches squared. That is the surface area, the area of all of the surfaces of this square pyramid. I told you so. Problem 3 was much faster, and so will problem 4. Let's go. Boys and girls, this will be the last problem that we will work through together, so please pay attention. And we have a triangular pyramid here. Once again, we can tell it's a pyramid because it has one base, okay, and then directly opposite of the base we have the pinnacle, this vertex up here. And also all of the side faces are triangles as well. Okay, now this triangular pyramid is pretty cool in that all of the sides of every triangle, they're all the same. Okay, all of these sides are the same according to this drawing. And it's kind of neat how things just kind of flop down. You have your base, and then each of the 3 petals falls down. I know this isn't to perfect scale, but I think you get the idea. All the sides are 12 feet. Okay, so all of these are 12 feet. And then it gives us one other piece of information. It tells us that the height, I'll have to do this upside down, the height is 8 feet, okay, for the base, and it also has a height, of 8 feet as well for all these outside, because all these triangles are identical. They're all identical. Okay, they all flop down the length of the sides. So here we have it, and all we really need to do is find the area of just one of these triangles, and that will give us the area of all the triangles, and we happen to have a total of 4 of them. Okay, but area is base times height divided by 2. Well, the base of each of these triangles is 12 feet. The height of each of these triangles is 8 feet. We need to divide that by 2. I'm going to cross cancel to keep our numbers small and easier to work with. 2 goes into 2 one time, 2 goes into 8 4 times. 4 times 12 is 48 feet squared. Feet times feet is feet squared. So the base is 48 feet squared. We also know that the 3 side faces. They're triangles, and they're all identical. They're the same as the base, so they're 48 feet squared as well. And we have another 3 of them, and 3 times 48 will be, we'll find the product of 144 feet squared. When we add the 3 side faces and the base together, we will get 192 feet squared. There you have it. That is a triangular pyramid, the surface area. Well, boys and girls, that's all I have for you today. I'm looking forward to seeing you tomorrow, and I know that Dr. Rothfeld and Dr. Nicholas are looking forward to seeing you guys tomorrow as well. That's it. Although, if there's any time left, you can get started on the remaining 5 problems, either in class or just do that for homework or whatever your teacher tells you to do. I'm sure that they know the right thing to do. Okay, see you tomorrow. Bye-bye.